Alright, we're going to work on proving triangles similar. First I want to revisit ratios because I know I haven't done one like this before. So my house is 18 feet tall and model of my house is 9 inches tall. What is the ratio of my house to the model? So like I said, I hadn't done one of these before because what we're talking about here is I have 18 feet and 9 inches. So I can't just make the ratio of 18 and 9 because we're not talking about the same units. And ratios need to have the same units. So I need to convert my feet, which is 18, to inches. So there's 12 inches in a foot, so I'm going to do 18 times 12. Multiply that out and get 216 inches. So my ratio is 216 over 9. Well, I need to reduce that ratio, so I can divide both those by 9 and get 24 to 1 as my ratio. So my house is 24 times larger than the model of my house. Alright, so let's talk about indirect measurement here. So what I have there is a person standing and he can see a spot of the ground that he can see the reflection of the height of the building. So he's 10 feet from that mirror, we'll just call it, on the ground, and the mirror to the building is 75 feet. So here we can use a proportion. So I can do the height of him over the distance to the mirror equals the height of the building, let's put a B, over the distance from the building to the mirror, which is 75. So we're going to cross multiply. I get 10B equals 6 times 75, which is 450. Divide by 10, and I get B equals 45. So the height of the building is 45 feet. Oh, that should have been a T. So that's like using similar triangles to find the missing height of that building. Alright, so let's talk about similar triangles here. So I got 65 and 45 angles measures for the first one and 45 and 70 for the second one. So we need to find one of those missing angles. You don't have to find both of them in this case because we're just trying to prove that they're similar or not. So let's do the 65 and 45. So let's do 65 plus 45. It's going to give me 110. And then 180 minus 110 is going to give me 70. So what you can see here is I have some similar angle measure. I got 45 and 70 in both of those. So they are similar based on angle postulate. If two of the angles are similar, that means by default the third angle is also going to be similar. If we work that out, we can prove it just so you can see it, but you'll see that it works out. So 45 plus 70 would be 115, and then 180 minus 115 would give us 65. So like I said, we didn't have to do that last step to prove that missing angle was 65 because we know the angle postulate will prove that two triangles are similar. Alright, there's two more postulates we need to go over, and that first one we're going to do is side angle side, and what that tells us is if I have two triangles and they have a congruent angle, and then we'll call this one ABC and then DEF. So in order for these to be congruent or similar, what we would need to know is that AC over DF is the same ratio as AB over DE. Because we already know angles A and D are congruent. So if that is a true statement, then it is congruent. So you would say triangle ABC is similar to triangle DEF. And that's only if that AC over DF equals AB over DE. Alright, so if we want to prove something similar based on side, 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 what we have to know are that the sides are proportional to each other. So you can think of that XYZ of just rotating that around until X comes on top, Y would be down there, and then Z. So that kind of helps you visualize it. So in order for this to be a true statement, AC over XZ would have to equal AB over XY, which would have to equal BC over YZ. Those ratios would all have to equal in order to prove something is similar based on side, side, side. So unlike proving congruence, we had to prove everything was equal. Here we have to prove the ratios are equal. So to prove similarity, it's all about proving that the ratios are equal.